So I know that this is clear as mud, right? But maybe in baby steps, it will slowly start to make sense as you do the calculations on your own and as you plug these numbers into Excel. But in the recent video, we talked about the standardization of hydrochloric, right? So I'm going to erase all of these notes that's up here because we're done talking about the hydrochloric acid standardization now, right? We have a concentration for hydrochloric acid, and we walked you through that calculation. I'm going to leave that number up here on the screen. 0.0398 is what we got. And we talked about the reaction and what we need to do as far as moles go, 1 to 1 to 1 to 1, and using that reaction and so forth. Okay, so now we need to talk about this whole concept of what to do now with my antacid. How do I calculate a concentration of an antacid this way? Right? That's kind of weird, kind of strange. What do I need to do? All right, so in this flask, I have a certain amount milligram wise of calcium carbonate tablet. That is my antacid tablet. Okay, but we said that in this flask we have also added in hydrochloric acid, and we've added a certain amount of milliliters of that hydrochloric acid in there. And the purpose of us adding the acid was to neutralize all of the base that was in that flask and make this thing acidic. Okay, well, let's kind of take it one step at a time. Let's say that I was required to add 10 milliliters of acid into this flask. I now know what the concentration was. I just solved for it. 0.0398. Now yours will be different, but I'm just using this as an example. But I have taken 10 milliliters of my standardized hydrochloric and I've added it into this flask. And I've neutralized all the base out of there, and I've made this thing acidic. Well, I can calculate the number of moles here. How many moles of hydrochloric did I really add in there? Well, molarity is equal to moles over liter. I know what my molarity is, 0.0398. The number of moles is what I'm trying to capture, trying to figure out. And the liters was 10 mils. Okay, well 10 mils converted over to liter is 0.01. So I'm going to pull up my calculator and I'll take 0.0398 and I multiply by 0.010 and I hit enter, and my moles will end up giving me 0.000410 of hydrochloric acid. So that's how much acid I added into the flask in total. Uh-oh. Something's going to be about that total because he wrote it and he circled it. So what is going on with total amount? Okay, so this is acidic. I then took that beaker or that flask that is acidic and I titrated that flask with NaOH. Okay, well, titrate, I got to a point where the color change happened, and this color change happens at a certain volume. So color change, and I record the number of milliliters of NaOH that it took in order to titrate that sample from acidic to basic again. The purpose of me doing that is to figure out how much was left over. How much acid was left over. That is why I titrated it. I knew that I slammed it full of extra acid. It neutralized all of what it could. And when all the base disappeared, I had leftover acid that was floating around. Well, I'm getting ready to calculate how much extra acid was in my flask. Because if I can calculate how much extra was left over, and if I know how much I started with in the very beginning, I can then do a simple subtraction to figure out how much was actually taken up by the antacid. Okay, so this is going to tell me remaining. How much remaining acid is swimming around? Well, in order to do that, I need the concentration of sodium hydroxide, and I need the milliliters of sodium hydroxide that it took. And I can use this in the molarity formula, moles over liter. Calculate the moles of sodium hydroxide, and that is equal to the moles of hydrochloric that it neutralized. Okay, so let's say that the concentration of my sodium hydroxide here is 0.1043. That came from a previous video. And let's say the number of milliliters that it took in order to titrate was 2.21 mils. So, added the acid, neutralized all of the base, I had extra acid left over. I took that flask and titrated it to figure out how much was actually left over, and that took 2.21 mils to convert over. Alright, so 0.1043 is equal to moles divided by the number of liters, 0.0221. Okay, so I'll take 2.21 mils divided by 1,000. Oh, sorry. Let me add a 0 onto that number. 0.00221. So I'm going to take that many number of milliliters, multiply by the molarity of my sodium hydroxide, and this tells me that I have 0.000231 moles of sodium hydroxide. That's how many moles of NaOH that it took to get this thing changed from yellow to blue. Well, that's also the number of moles then that is left over in my flask of hydrochloric acid. Well, if this is how much was left over, and I began with this many number of moles, I can take those two numbers and subtract them. 0.000410 minus 0.000231, and that gives me 0.000179 moles of acid that was actually used up. Now, this is acid that was used, not antacid that was used. That's how many moles of hydrochloric was used in the reaction between it and the antacid. Woo! It's a lot of stuff. A lot of stuff to keep track of. So let me review that again. Took a flask, added a tablet to it, added acid to it, with a little bit of water and a little bit of indicator. I know how much acid I added in. I pipetted that amount, 10 mils. I know the concentration of that acid. I standardized it from a previous run. So if I know the molarity and I know the volume, I can plug that into the molarity equation, and I can solve for the number of moles of hydrochloric. This is how many total moles of HCl I added into that flask, period. That's how much in total I've got. Okay, well, with that total amount, I can then take that number, and that acid is going to be used up. A certain amount of this is used up to kill off all the antacid that's swimming in that flask. To figure out what that number is, I take this flask that has extra acid and I titrate that acid. How much is left over? So I know the concentration of sodium hydroxide. I know the volume that it took for the titration to go from yellow to blue. I plug that into the molarity equation and I get the number of moles of sodium hydroxide. It's a 1 to 1 to 1 to 1, so that's also the moles of hydrochloric that I'm using. So that's how many moles of HCl is left over. So if I started with this amount, 0.000410, and if this is how much that's left over, then if I take the difference between the two, that tells me how many was used up. It tells me that the antacid took 0.000179 moles of acid in order to neutralize itself. So in the next video, we're not done. We'll talk about what to do with this number after this point.